Assalamualaikum and good evening. Today our group will be presenting our assignment 2 for scientific inquiry. Our article title is The Effect of Temperature on the Mechanical Properties of 3D Printed PLA Tensile Specimens. These are the group members. Firstly, for the summary, the overall objective is to examine the effect of various thermal conditions on the mechanical properties of polylactic acid PLA used in a standard 3D printer machine. The method of this article is a total of 75 printed specimens undergo tensile tests at the different temperatures, and each category is repeated at least 5 times to reduce the error. The results that the research found is that the higher the temperature, the more it can be elongated.
For the overall study of the paper, the intention and the research question was pretty clear for the readers, showing a strong goal to optimize 3D printing settings for thermally sensitive and structurally critical PLA components using different temperature ranging from 20 to 60 degrees Celsius and using angles, 3 different angles. However, it's not a perfect display of its objective as some explicit research question and thesis statement was missing. The study never states its research question in a single clear sentence, which may confuse its readers about the study's central aim. The clarity could be strengthened in the introduction by including a direct thesis or research question in the introduction, which would overall improve the clarity to the reader's orientation. But overall, the direction is pretty understandable for the readers, even though its weakness, the study objective can be understood throughout the content and structure. And for the appropriateness for the methodology, relevant testing conditions were chosen using tensile tests under 5 different temperature with 3 infill angles to appropriately reflect factors influencing PLA performance near its glass transition temperature, which reflects most real-life world use. Also, the study used 5 temperature and 3 infill angles 5 times, which overall adds up to around 75 specimen, allowing calculation of averages and standard deviation for more statistical robustness. However, it lacks advanced statistical analysis, such as ANOVA analysis, which could have better clarified whether the group differences were actually significant to each other. But overall, the method aligns with the study goals, which is to investigate which printing setting is the most optimal for PLA under thermal stress.
Okay, next will be the validity of results and data interpretation for this article. First of all, is the optical variables. The temperature was initially set from ranging from 20 degrees Celsius to 60 degrees Celsius with 3 different infills, which are 0 and 90 degrees, 30 and 60 degrees, and 45 degrees. Each condition was tested 5 times as previously stated, so this will ensure the statistics are reliable. Besides, they also follow the ASTM D638 standards using an instrument machine, and the temperature was carefully controlled with an infrared camera and preconditioning steps to ensure the uniform heat distribution. However, the external validity is limited since the findings are based on PLA printed products with 3D printers, so the result may not apply to others printer or material. Next will be the data interpretation. The study analyzed key mechanical properties like the Young modulus, UTS, strain, and stress at failure. They found that the stiffness and strength consistently decreased as the temperature increased, especially near the glass transition point, which are 60 degrees. So this trend was also supported by polymer's behavior theory and microscopy image showing different failure modes. The example include chain mobility, cold crystallization, bonding surface deformation. Microscopic fracture analysis revealed the necking patterns and failure modes. Overall, while the results are credible and aligned with the material science principle, the study could be improved with clearer definitions of failure, analysis of internal defects like porosity, and deeper statistical modeling.
Alright, I'm Shahmi and I'll present the limitation of the study. The first limitation is temperature measurement limitation. This study used infrared or IR camera to measure temperature during tensile testing. However, IR cameras only capture surface temperature and do not count the internal temperature profile for the specimen. This leads to uncertainty as internal temperature, which affects PLA's mechanical behavior. Next, the stress calculation inaccuracy. The stress was calculated based on external dimensions that ignore the internal voids or porosity. Voids are common in FDM printer pipe and reduce the actual load-bearing area. This may result in an overestimated mechanical strength of the material. Then, the third limitation is the limited testing condition. The testing was conducted under static load and a narrow temperature range, which is 20 degree to 60 degrees Celsius. The rearward parts often experience dynamic loads, impacts, and a wider range of temperature, which this limits the applicability of the finding to the practical in real life application. Next, specimen geometry not representative. The rear parts in this study, specimen had a parabolic shape to avoid failure outside the gauge length. This design does not reflect the typical or complex geometry of real 3D printed parts. The study lacks the analysis of stress effects from hole, notches, or non-uniform shapes. Lastly, the small sample size from study. The only 5 specimens were tested per condition. This number may be statistically valid, but not capture high variability in additive manufacturing. However, this can be solved by do larger sample size. So this can improve the statistical power and also the result reliability. That's all.
Hello, I'm CKJ. I'm taking part of significance. This study is significant because it examines how both temperature and infill orientation affect the strength of 3D printed PLA parts, giving a more complete and realistic view than many past studies. By testing temperature from 20 degree to 60 degree, it shows that mechanical properties like yaw modulus and tensile strength drop as heat increase, which helps designer avoid broken parts by showing what condition could cause failure. This helps designer understand what condition may cause failure, which is useful for improving the safety and reliability of parts used in medical devices, cars, and consumer products. Overall, the study highlights the value of experimental analysis for enhancing reliability in additive manufacturing. Thank you.
And lastly, for conclusion, Russell et al. 2018 explore how temperature affect 3D printing PLA using a solid testing approach with varying temperature and infill angles. Even if the research topic should have been expressed more clearly and there was a lack of in-depth statistic analysis, and also the drawbacks such as small sample size, straightforward shapes, and a limited temperature range, the study was well controlled and the results were interpreted correctly and can also provide insightful direction for creating PLA parts that are more robust and dependable. That's all from us. Thank you.